We've reached the point in our technological evolution to where another one of those inflection points is upon us. Years ago, server virtualization began to take shape. I want to say 2006-ish, when it really began to demonstrate that it was a technology worthy of deployment in enterprise production environments. Prior to that, it really helped revolutionize the way organizations handled development and test scenarios. VMware and their ESXi product, arguably the most known solution in the space, but perhaps not the most flexible. KVM, the Linux kernel virtual machine, the solution found underneath the largest of the large public cloud serving environments. I dare say a leader in the space. I'm going to evolve my knowledge in this area over the course of the next several weeks by taking some applications that I've written in the past and moving them into what's now in vogue, a technology known as containerization. But before I do that, I thought it would be worthwhile to take a little bit of a look at history. And so we'll do that in this video. So let's talk a little bit about the evolution of application serving, the road to containers, as the slide indicates. In the early days of PC servers, we had little choice in the way that we deployed applications to the business. In fact, it was quite expensive, and interestingly enough, you still see some of this today. A business will go out and acquire hardware. On top of that hardware, the business would install an operating system. In this example, we give Ubuntu server, Ubuntu Linux server. This could be Windows server, could be, AIX, it could be Unix, it could be a number of things. The point here is we acquire hardware and we install an operating system. An operating system by itself does little for productivity. So on top of that operating system, we would deploy an application. And in this example, we're using MySQL, the database server, the open source database server, but this could be any number of things. Postgres, it could be Microsoft Exchange, it could be SharePoint, it could be anything. The point here is we had one server to one operating system to one application. A very expensive model, capital intensive model, as we might say, but there wasn't a whole lot of choice back then. So as time went on, we got smarter. We had new open source technologies come to fruition, and we were able to get a bit more intelligent about how we handled serving applications to the business. But before then, to take another look at just how expensive that old model was every time we needed to serve a new application, we acquired a new server, we installed a new operating system, and then we installed our application. So capital intensive, administratively intensive. As you look at this depiction, we have maintenance windows associated with the application. We have maintenance windows associated with maintaining the operating systems underneath those applications. And we have maintenance windows associated with the hardware itself. You've got to do firmware updates. You're going to have hardware failures, etc., etc. So pretty intense. We needed a better way. Server virtualization, the revolution. So we got to a point where we could acquire these hardware solutions, but instead of installing the operating system directly on the hardware, we got this little piece of software that we call the hypervisor, and it could sit in between the hardware and the operating systems and do some smart things. Now, a little segue here. Oftentimes you will see the hypervisor is quote unquote included as a part of the operating system. A little bit confusing to look at in that light, because it looks like the general purpose operating system has control of the hardware and is providing the virtualization services. That model is known as a type 2 hypervisor. In this little educational snippet, our focus is on what we call a type 1 hypervisor, where it is in control of the hardware completely, and we install operating systems on top of it. And in this example, we have installed 3 instances, or we have 3 virtual machines, 3 instances of Ubuntu server running on this hypervisor. And then we can take our applications and deploy them just as we would on those operating systems. Now, we solved the capital expense problem. We have, quote unquote, solved our hardware maintenance problem. We are still going to take an outage, and granted, while we have one entity in this model to deal with as it relates to dealing with hardware updates, etc., the outage impact, also known as the blast radius of the event, is now magnified because we have 3 operating systems, 3 different application suites that are now impacted by this single outage. So not perfect, but we're still solving one part of the equation. And oh, by the way, you could take this model, replicate it in such a way that as you need to do maintenance, the operating systems and applications dynamically move to another piece of hardware while that maintenance event is underway. So a number of ways to get around the challenge of maintenance. But still, we've got 3 instances of an operating system. Those still need to be maintained. 3 different application suites. Those need to be maintained as well. This model works pretty well. We see this, I dare say, as the dominant model today. Virtualization is everywhere. The virtualization of everything is pretty much a reality these days. But for all of the challenges that I've mentioned from a software maintenance standpoint, we have now determined that there is an even better way. the rise of containers is upon us. In this depiction, I have one hardware resource, I have one hypervisor, I have one instance of an operating system running on that hypervisor. And now I have the ability, with smart technologies like Docker and things like it, to take those applications and package them up into what are known as containers. Those containers, in turn, run on a single operating system instance and use all of the same operating system centric resources. These containers also have the advantage of being packaged with all of the supporting software required for them to run independently. And so now in that model where I have multiple VMs supporting a bunch of containers, and that ability to fail over, fail back, fail across during maintenance events or unforeseen challenges in the environment, my flexibility increases quite significantly, giving the business true agility in the way that it serves applications and, as a byproduct, its customers. Thanks for stopping by the channel and spending a little bit of time to watch the content. If you've hung around this long, it's reasonable to assume you enjoyed the content. If that assumption is correct, please hit the like button. It really helps out the channel. Also consider subscribing, as I post videos from time to time on interesting topics like this one, some of which you can see to my right.